All right, so this is going to be a review of translations and reflections. Okay, does everyone have their paper ready? Okay, so we're actually going to start with reflections. Number 1 says plot the following points on the coordinate plane, which is located down here. This is for number 1. This is for number 2. Okay. Connect the points as you go to draw the figure, and then reflect the figure over the y-axis. Okay. Now there's 2 ways to do this, and I'm gonna kind of show you both. Right, we've done both. One is going to be using the drawing, using the image, and the other is going to be using the rule. Right. What we did on the warm-up is I showed you wrote the rule. Okay. So, and you did that for translation, but this is reflection. And there's only 2 different rules, so they're not hard to remember. First of all, let's draw some of these points. So I want you to go ahead and plot these points on this graph. So like 2, 6 is going to be 2 and 6. And label that with an A. 7, 6, 7, 6, B. Right? 7, 4. Okay, you should be doing this on your own. Hopefully you're faster than I am. I'm a little bit slow. Notice how I do this. Okay, because I still see some of you do this like you do your y value first. Always go your x value first, your x-axis. Write that original number line that you learned in elementary school. Okay, and then you do your vertical. Then you go up or down. So in this one, we're going to do 7, 10, 7, and then go up 10. And we have 7, 8. And finally, 2, 8. Okay, connect your dots. What shape do you have? Looks like the letter T. Okay, so that is what's called the, I'm going to write it here, the pre-image. Right, this is like, if we have Transformers, right, it's still the car right now, okay? This is just Optimus, no Prime, okay? Now what we're going to do is we're going to transform it. How are we transforming it? It says to reflect the figure over the y-axis. So I want you to go ahead on your graph. I want you to draw a line through your y-axis. Which is your y-axis?
Up and down.
Up and down. So draw a line through that. Okay. Now you can either, right, I'm going to do a little bit both ways. You can either just start reflecting it, right, and we know what a reflection looks like, right, because we have all looked in a mirror, right, maybe not today, but at some point.
What if it broke?
7 years bad luck.
Sure. A, right, basically when you look in a mirror, what do you see? You see your reflection, so it's flipped, it's a reverse image of yourself, but it's also the same distance, right, from how far you are from the mirror. So A is 2 steps from the mirror, so A prime is going to be 2 steps from the mirror on the opposite side. Okay, H is 2 steps, H prime is 2 steps. And so you can kind of just go through and do that for all of the points. This is 7 steps away, right? And I don't notice, I'm not counting at this point, I'm just looking where it is on the number line. 7 steps away, so I'm going to go out 7 steps away here. And that would be B prime. Okay, so you can keep doing that. I'm going to show you another way that does this pretty fast in terms of getting what our values are, because after you draw this, you'd still have to go back and figure out, okay, what are those ordered pairs? So going back to the top here, what's happening to our values? Well, we're reflecting the figure over the y-axis, and there's only 2 different things that can happen. Okay, there's a little kind of not cheat sheet, but little diagram to remember this by. This is just our axis, right? XY axis where we have our different quadrants, 1, 2, 3, 4. All of the values here are positive, right? The x values are all positive, the y values are all positive. All of the values here the x values are all negative, the y values are all positive, and all of the values here, the x values are all positive, the y values are all negative. Do y'all understand what I mean when I say that? Is anyone confused? Like if I plotted a random point like this, right? No matter what, right, it could be positive 5 and then negative 2, right? So no matter what, anything in the fourth quadrant, right, is going to be a positive number followed by a negative number, right? And so our x, y values, it's going to be x, comma, negative y, right? This would be negative x, comma, positive y. Or you don't have to put a plus sign. Okay. And so this being x, y, kind of your starting point, right? Even if it doesn't start necessarily in this quadrant 1, right? This is quadrant 1, 2, 3, and 4. Anytime you flip over the y-axis, right, what happens to your values? Well, y stays the same and x changes. Okay, so if you're flipping over the y-axis, which is what we're doing here, what is the rule? The rule is negative x, comma, y. What happens to x coordinates? They're going to flip, change, whatever you want to say. What happens to y stays the same. Stays the same. Okay? If you're flipping over the x-axis, which value changes? Well, your x value is in the same spot, right? That stays the same. On this number line, you're in the same location. But your y value flips now. Okay, so if you can remember this, right, then you can remember those two rules. And the reason, right, I'm showing you this is because when we do rotations tomorrow, we're going to have a little diagram like this. It's going to be a little more filled out. But that's going to be what helps you remember how to rotate things. Okay? But it's going to follow these same principles. Any questions so far? Okay, so knowing that now, check this out, how easy this is. A, it was 2, 6. Y is staying the same, right, for all of these, right? I could just go ahead and go y is the same, y is the same, y is the same. What's happening to our x values? They're just flipping signs. So it's negative 2, 6. It's negative 7, 6. Negative 7, 4. Negative 9, 4. Negative 9, 10, and so on and so forth. Right, so the only thing that happened is all of our x values get a flip. They reflect. Okay, so you can fill these out really quickly without actually having to go and say, okay, what is a prime? A prime is negative 2, 6, right? You can do it that way, but if you know what the rule is, it's much faster. So you'll finish drawing the image on your own in a second here. I do want to go ahead and flip it over to the back page now. So go to number 3, and the reason I want to do that is because this is a translation now. Okay, so this is the other transformation we've learned. Plot the following points on the coordinate plane, connect the points as you go, then translate the figure 5 units to the left, and I like to draw an arrow with the number and then 13 units down. Okay, so what is happening to each of these values, right? This is a point, right? It's a dot in a two-dimensional plane. It's moving 5 spaces to the left and 13 spaces down. Okay. This is also going to have a graph where you can do it graphically to understand, but you can also just do this algebraically, and it's pretty easy, right? This is exactly like our warm-up now. Okay. So can anyone tell me what the rule is for this without moving any further? How would I write the rule? X doing... So it's not a reflection, right? This is a translation, so we're going to be adding and subtracting. If we're moving 5 to the left, is the... 5 minus 5. Which axis is left and right? X. So is it moving, is it adding or subtracting? Minus. So we just put x minus 5. And then y is moving down 13. Plus or minus? Minus 13. Okay, and so these are actually easier a lot of times to get the rule first, right? Because it's telling you the rule, you're just translating it to math, which we've done a lot this year, right? We have English, we need math, we need algebra. Okay. And then with this rule, before we even look at the graph, with this rule, I could go ahead and solve all of these.
Mr.
Yes?
Whatever makes each name is the left and the right. Like, how is that supposed to Like on a number line?
Exactly, right? What is a graph? A graph is just two number lines.
So this side is, if it's going this way, it's got to be positive, then it's positive.
If this is a number line, right? This is how number lines are written. We have positive numbers going to the right, and we have negative numbers going to the left. Does that look right to you? Right, so that's our number line. So if we're moving to the, so for example, that's a good question, Lily. So let's say we have a 4 here, and this is a number line. It's also your x-axis, if you can see it, right? We've talked about this before, that a graph is really just your good old number line you learned in elementary school with this new number line that we stack vertically on top of it. Okay? So if we start at number 4 and move 5 to the left, where do we end up? 1, 2, 3, 4, 5. We end up right here. Okay, and what is 4 minus 5? What is 4 negative? Exactly, right? And see, look, where are we? We went from 4. We can say this is, part of our point, and this is our prime number. Okay, 4 to negative 1. Right? That's our x value in this coordinate right here. And so we have negative 1. And then 3, we can do the same thing, only this is acting on a number line going up and down. And this should be intuitive to you, I think, right? As in, like, this isn't something that goes against common sense. Is up positive or negative? Positive, right? And down is, like, you're feeling down in the dumps, you're not trying to tell someone you're having a great day, right? Okay? You're high in spirits or other things, right? 0, 1, 2, 3, negative 1, negative 2, and so on and so forth. So we've got 3, which is right here, okay, and we are going 13 units down, so that's going to go off our number line, but we're just going to end up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That would actually end up at a negative 10, okay, which is just subtraction, right? I've tried to, make sure y'all see that connection. That when we're counting, the reason I like when y'all count with your fingers, counting, right, with your fingers, adding, subtracting, that's the same thing. Okay, you can do it quickly because you've done it often in your head. 4 minus 5 is negative 1. 3 minus 13 is negative 10. 6, I'm going to write it differently this time. 6 minus 5 equals what? 1. Good. And then 3 minus 13 equals what? What's 3 minus 13? We just did that. Or no, yeah, we just did. Negative 10. Okay, so you see how you can use the rule, right? Yes, you can use the rule, the x and y values, and you just take away, in this case, 5 and 13 from each of them to get all your new points. Okay? That's translation. What does that look like on the graph? Well, if we had our picture graphed, this one 4, 3, that's A. I'm going to do a few of these points. And then 6, 3, 6, 3 is B. And then C is 6, 8, 6. Okay, so hopefully you can kind of start to see that shape forming, right? But you'll need to do, plot all of them. We're going to be moving 5 to the left and 13 down. So for A, just like we did on these number lines that were separated, right? We're just going to do that for these two number lines here. We're going to start here, right, at 4, and we're going to move 5 to the left, 1, 2, 3, 4, 5, and then we're going to move 13 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And what do you know? Look at the point we're at. A prime is negative 1, comma, negative 10. And so we saw that with adding, subtracting, or with counting on our graph, we're going to end up at with the same result. Are there any questions on this? Okay. I'm going to have y'all work on this now. Probably about 20 minutes to finish all this for everybody. And then we will do a Kahoot, and then we'll take our quiz next period.